Hi, my name is Sergio Martinez, and with Humberto Morales, Jose Adrián Garza, and Alejandro Cerda, this is our statistics final project, which our topic is hypothesis testing for the mean, where t-test is needed. We're going to explain the general idea and a sample in a detailed manner showing all 8 required steps of the process.
First of all, we need to understand what is hypothesis testing. We need to use the t-test. The t-test is used when we're doing 30 or less tests. Keeping this in mind, you need to have your t-test table in order to understand the data that you have. Hypothesis testing has 8 steps, all of which are followed in order to get to a conclusion of which hypothesis is correct or incorrect, the null hypothesis or the alternative hypothesis. A null hypothesis has an equal, less than or equal to, or more than or equal to sign. An alternative hypothesis has less than, more than, or an inequality sign. The 8 steps are as follows. Number 1, stating your claim. Write down the keywords that the problem is asking you for. For example, maybe the claim says that the average weight of third graders has decreased. So you state both your hypotheses, which is step 2, stating both your hypothesis, the null hypothesis and the alternative hypothesis. Third, you need to write down all the information that you have. The mean, the standard deviation, everything that can be found inside the problem must be written down. The fourth step is to graph the information in order to see where it falls, in the fail to reject zone or the reject zone. You need to divide those two zones in order to continue to see what the hypothesis, which hypothesis is true, which one is not true. Next, we need to use the formula of x bar minus mu over s standard deviation divided by the square root of n. Now that we use that formula, with the number that we get, we need to see if it falls in the fail to reject or the reject zone. Depending on which it lands, for example, if it's the fail to reject, it means the hypothesis was failed to reject. So it is probably true, and the reject zone, if it falls in the reject zone, it is probably not true. Now, once you state this, write your statement if it's correct or if it's incorrect and everything that involves the hypothesis.
Let x be the random variable that represents the number in millions of red blood cells in male students in the class of Mr. Jose Andres' class. In all the year of Mr. Jose Andres' class, the average has been of 4.8 million red blood cells per student. This year, we only tested some students, and these are the following results. One student have 4.9, one student have 4.5, one student 4.4, 4.2, 4.3, and 4.1 million red blood cells. Using a 0.05 as your confidence level, does the data indicate that the new class has a lower red blood cell count than the previous classes? First, we need to say our statement, which in this case will be the new class of Mr. Jose Andres has a lower red blood cell count than the previous generations. The next step will be to say our null and alternate hypothesis. In this case, our null hypothesis is that mu is greater or equal than to 4.8, and our alternative hypothesis is that mu is lower than 4.8, which in this case this will be our correct answer. Now in step 3 we have to indicate all of the data that we have. In this case we need to add every single number and divide by 6, which is the number of students that we took tests from, and that will give us our mean, which is 4.4 in this case. Now to get our standard deviation or S, we have to square root the sum of all the numbers minus the mean squared divided by the n-1 rule, which in this case is 6 minus 1, which will give us 5, and all summed up our S is going to be 0.283. As we already know, our mu is 4.8 and our number of sample is 6 students. Now to get our t calculated, which in this case is 2.015, we're going to use our degrees of freedom, which in this case is n-1, so it's 6 minus 1, which is 5. Now we're going to search that on our table, that is going to be the t-table, and we're also going to use the 0.05 confidence level that we're given here, and we're going to find it. So 0.05 in the one tail to the which is to the 5 level of degrees, which is 2.015. That's how we get our T critical. After that, we're going to draw our rejection zone and our fail to reject, and we're going to put our T critical right here in the middle and see if the number is bigger or lower, and that's how we're going to specify if we're going to fail to reject or if we're going to reject definitely our claim. Now that we have our T critical, we're going to use the formula already stated to get our T calculated. Using the formula, we're going to put the average of the students right here in 4.4 minus the average of all the students of all the years that Mr. Jose Andres has had, divided by 0.283, which is the S, over the radical of the students that participated in the survey, which are 6 students. This is going to end up with negative 3.46, which is going to fall into the rejection zone right here. In this case, our final claim is that there is sufficient information at a level of 0.05 confidence level to claim that the amount of red blood cells is lower than 4.8.
Well, in conclusion, we want to say that at first it was very difficult to understand the whole process, because the final part where you decided if it was rejected or accepted the hypothesis, we think it was very difficult. And also to get the whole idea of the problem, it was tricky, but we could understand it. And also we think this is a very basic way to explain a concept you can study in many different ways, and this can also be applied to every single problem in daily life, because there's always a way to find a solution, but obviously you don't know by 100% if it is accepted or rejected in this case. Also, we think, this is basically a way of testing quantitative processes, but we are not 100% sure if it is 100% truth or not. So that's why it's an educated guess, as people call it, to the hypothesis. And in other words, we're never gonna be correct 100%. And also, finally, this was a very difficult project in some aspects, but we think at the end we solved it very well. And also, we thought that it was a good idea to transmit this message in a better way, and so that's why we had a hard time communicating it. And also, to add, this was the best project in this semester. So thank you, Mr. Andres,